Hi, today we would like to present our project, Bidirectional Visitor Counter. Have you ever wondered how many people are in a room right now? Our project helps solve this problem using a simple and affordable system. I'm Nayrunda and I'm going to talk about the overview of this project. Start with the concept. This system is designed to automatically count visitors entering and exiting a room or area using two IR sensors and Arduino Uno microcontroller. By comparing the sequence in which the sensors are triggered, it can track how many people are currently inside. How it works? The bidirectional visitor counter uses two IR sensors at the entrance. The Arduino Uno detects the sequence in which the sensors are triggered. If the first sensor is triggered before the second, it's counted as an entry. The system increments the count. If the second is triggered first, it's counted as an exit. The system decreases the count. The system updates the count of people inside in real time, displaying it on the LCD display. The purpose of bidirectional visitor counter system is to deal with the issue of overcrowding and tracking how many people are in a room. In environment that is difficult to track the exact number of people, and this system ensures that the number of people is monitored in real time, helping to prevent overcrowding, enhance safety, and facilitate better space management. The component used in this project includes an Arduino Uno with a USB cable, which serves as the main microcontroller, and two IR sensor modules that detect motion to determine entering and exiting. A brain board is used to assemble the circuit, and male-to-male jumper cables are used to connect between the electrical components. Additionally, the system includes a LCD display to show the current number of people, an LED to indicate system status or alert, and 1 kilo ohm resistor to limit the current and protect the LED from damage. Then let's see how this system works.
Here's a somewhere store. When customer walks into a store, sensor detects their entry. Red light turn on to alert the staff to prepare for servicing. The staff screen also displays the current number of people inside. When customer leaves, another sensor detects the exit. The screen updates the number of people inside. If there are no customers, it notifies staff so they can do another task. Hi, I'm Supravee. I'm going to present the circuit and code description and demonstrate how the system works. This is our visitor counter circuit showing here. The system counts how many people enter and leave a room, then calculate the current number of visitors. The light turn on or turn off, depending on whether someone is in the room. The system is designed to count the number of people entering and leaving a room. It uses two IR sensors, one at the entrance and one at the exit. When someone enters, the system increases the count, and when someone exits, it decreases the count. When the system first starts, the count is 0. That means the room is empty. At this point, the LCD screen displays no customer on the first line and no service on the second line. The LED light is remain off. The count starts updating when the IR sensor detects a visitor. The LCD displays the message number of customers on the first line. However, as you can see, on our LCD screen, it only shows number of customers because the LCD can only display 16 characters per line. Due to the spacing and character limits, the full sentence does not fit. The current number of visitors is shown on the second line of the LCD screen. Based on this count, the system controls the LED light, turning it on when people are present and turning it off when the room is empty. When the room is empty again, the LCD returns to showing no customer and no service. The light is also turned off. And here's the cross explanation. Start with the first one at the top, so you can see include y.h and include liquid crystal I2C.h. It is an important library to control the I2C LCD that we have added. The Y library is used for I2C communication, which allow the microcontroller to communicate with I2C device. Next, liquid crystal I2C helps to control the LCD screen. At line 4, this one shown here is address column and row, so that we initialize a 16x2 LCD display address of 0x27, and here the object name LCD that we have assigned to it. Then we declare a variable for the sensor and LED pins over here. Variable in as a pin 3 is used for the entrance sensor. Variable out pin 5 is used for the exit sensor. Inval and outval are the variables used to store current reading from the entrance and exit sensors. LED as a pin 6, and the last one, a count variable, is for keeping a track of how many people are currently in the room, and their set that start with a 0. Here for the setup, you can see a pin mode over here. It is a function used to set a pin to work either as an input or an output. So you can see here pin mode with a variable in. This set the pin connect to the entrance IR sensor as an input, so it can detect signal when someone is entered. And the next one is for our variable that it's a exit IR sensor. This is for set as and also an input to detect someone leaving or passing a sensor. Next is for LED pins. It's at an output which we turn on or turn off depending on current visitor. For the LCD in it initializes the LCD screen, so it's ready to display the message. And the last one, the backlight. This turns on the backlight of the LCD. For loop at line 22, which run continuously over and over again throughout the operation of the program. To check the status of the sensors at line 23 and 24, we use the digital lead. So let's see the line 23. Digital lead in is used to read the pin that connect to the entry sensor, and digital lead out is used to read the pin connect to exit sensor. This function returns one of two values, high or low. If they are high, it means that no object is current passed in the sensor, but if it's low, it means there are objects that pass through the sensor. In our loop, there contain 4 conditions in the loop. First one is when the visitor enters the room. If someone walks in and triggers the entrance sensor, the system detects a low signal from the sensor. Then let's see the count plus. They increase the count by 1. The number of customers showing on the first row of the LCD. And then we have set the cursor. Now I think I have to say something that I have used 16x2 LCD, which means the first row is indexed as a low 0, the second row is a low 1, and the column go from 0 to 15 starting from the left. We use the command rcd.setCursor01 to move the cursor to the left of the second row, then the current visitor count is printed on that row. Let's see at line 31, delay 1000. This creates a 1 second pause before allowing any feature change to the count, and then clear the LCD using LCD.clear to get it ready for the next update. For the next conditions, when a visitor exits the room at line 35, it looks like the first condition, but if someone walks out or trigger the exit sensor, the count is decreased by 1. The message delay 1 second and clear is same as previous condition. The third one is when there are no people in the room. Visitor count becomes 0 or no current visitors. The system runs the condition else if count equals 0. In this case, the LED is turned off using digital LED low. On the LCD, we display a message to inform the user that no one is in the room by using the LCD set cursor 00 to print no customer in the first line, and use the LCD.setCursor01 to print no service in the second line. Delay 1 second and then clear. And the last condition, the fourth condition, when someone is in the room, there is the else part of the loop, which means the count is greater than 0. Operate command below. In this case, the system turns the LED on using digital white LED high. There is no need to update the LCD. This condition keeps the LED turned on to show that the current visitor or account is greater than 0. And here, that's all for our course explanation. Here are the credits. Thank you for watching.